and he's there ready and waiting. So rather than having to listen to me any longer, I'll hand you over to Oli. Hi, Oli.
Hi, Richard. Thank you very much. Absolutely wonderful seeing all the people joining in and just seeing that number tick up. I'm just flicking through the screen and seeing how many people have come back from last week. So it's wonderful to see everybody again. I'm just going to share my screen, so hopefully this will pop up okay. Richard, can you just let me know whether you can see that okay?
Oli, yeah, it's just coming up now. That's there now, no problem.
Fantastic, absolutely fantastic. So, like I say, welcome back to everyone. Thank you very much. Nothing important, Michael, don't worry. So, like I say, it's great to see so many people back from my previous session. Hopefully, everyone was in the previous session or was able to catch up, because we're going to be building on some of that. But the first thing we're going to do, obviously, we're going to have a quick recap of last week. We'll have a quick discussion. We'll do the practice activity, which is something I found really useful as a learning tool for myself, and I just want to share that with everyone. Then we'll have a bit of discussion at the end. So last week we discussed what the Arduino was, and the key thing we looked at there really was why would you use the Arduino as opposed to something like the Raspberry Pi. And the Raspberry Pi, as I said last week, is a fantastic piece of kit. But for the kind of thing for IoT, for the devices I'm interested in, it's just a bit too big and uses a bit too much power. And the Arduino, I feel, for my interests, does a better job. We looked at different ways of putting the I. Yes, we will, Robert and I, we will be using Tinkercad again today. So we looked at different ways of putting the I into IoT, and we looked at a whole range of the connectivity options. And primarily, really, it's a balance between what's available, and then a balance between the range that you need to be made, the power requirements, the cost, and sometimes the complexity. Again, for what I'm interested in, I tend to be using Wi-Fi because it's something that I have Wi-Fi everywhere in my house and in my garage, and the devices I've been developing, Wi-Fi has been suitable, but there are loads and loads of different options. We built a circuit on Tinkercad, and I'm just seeing that Robert and I love Tinkercad, so that's fantastic. I'm starting to love Tinkercad as well. I've created a lot, even since our last session. I've created about 5 different circuits. So yeah. So last week we made an LED responsive photoresistor, and then for those of you who were falling asleep, we added in a buzzer, which made some people jump through the roof. And the intention was to try and salvage some mistakes, which is something I'm a real big fan of. But unfortunately, time got a bit tight, and we didn't get a chance to do much of that. So hopefully we'll have a look at that later on. So I did ask you guys to try and find out a few things, and just look for some exciting IoT devices. So I'm going to take you through 3 that I found that I just thought was a bit interesting. While I'm talking for the next 2 minutes, can you guys just chuck a couple of lines into the chat? Just anything you found out that you thought was exciting, what you thought was exciting about it. So I'll give you a couple of minutes while I'm talking to throw some things down. So I found out about this thing called a Spark, and I drive a really rackety old 17-year-old MG convertible when I can now. And as anyone that's ever heard of an MG knows that they have a tendency to either rust or go wrong. The rusting we can't help with, but the going wrong is a pain that these things can help with. So you plug this into the ODB port in the car, and it does things like if you have an accident, it'll call to make sure you're okay. It gives you the faults and tells you what's going on. It can call mechanics for you and do some diagnostics. It's just a really clever little thing that I think you can modify your car with. So I like that. It also gives you a 4G connection and a Wi-Fi hotspot in your car, which opens up other opportunities as well, I'm sure. I found this, which was great. This is a cassette tape, which the older of you will, I'm sure, remember. And what they've done with this, they actually used Raspberry Pi Pi Zero, but I think it'll be even more suitable for an Arduino. And it's got a little scrolling thing on the center there, this bit in the middle. It's got a scrolling LED screen, so you can actually tweet it or whatever and get to scroll things across. And this was the idea of this was to have it as a badge or a little display case like this. I just think that's really cool. It really appeals to me as an absolutely useless but really fun use of IoT. So I love that a lot. I like this as well. It doesn't look like much, but this chap set this up as a completely immersive tomato. What was it called? You call it a tomato home farm bot, and it does pretty much everything. So it monitors temperature, humidity, luminosity, soil moisture levels. It's got visual and sound outputs for the status. It turns on pumps, it turns on lamps, it stores the data locally and in the cloud, and it's got a display screen to show you what's happening as well. And as not just me, my entire family is completely incapable of keeping anything alive apart from our children for more than about 2 minutes. I just think it's fantastic because if I had this, I might actually be able to grow at least one plant to fruition. So I think that's really cool. And you can see there he's got things like a reused milk box, and he's done all sorts of upcycling. So I think that's an absolutely wonderful use of technology that's got my heart right behind it. So we've not got much in the chat. Robert and I have been talking about circuits. Seth, you've mentioned code generation. Do you want to just give us a line about that maybe, or have you got anything else to say about that? So if you've got anything else to add, I'll let you add it in. I'll skip to the next screen because you could take some time to type if you have got anything to say. So what we're going to do today, we're going to be using Tinkercad again, and as we said, we love it just because it makes life. Okay, Seth, maybe we'll have a. I'm not seeing the link towards the IoT, but maybe we can have a chat about that later when we've got some time and get some more details, because I'm sure it's very interesting. So we're going to be using Tinkercad again, but we're going to be changing a few things up. The circuit we're going to be creating, if I can get the link to work, oh, it's going to be a pain. I'll put the link up in just a second, but the circuit we're going to be creating, we're going to be using a bigger breadboard because we've got more stuff on it. We're going to actually join together these rails that run right across the top and the bottom of the breadboard. We're going to join them together with a ground cable and a positive cable, and that means we can pick up the power from either side of the breadboard, which is going to make our lives a bit easier. We're going to use some push buttons, and the important thing to remember about the push buttons is where the gap is. The gap isn't across the center. The gap is actually between left and right. So at the moment, there's no current coming, if you can follow my mouse, from here to here. But when we push the button, the power will then flow between those two pins. So I always think that the gap, if you like, the thing you can turn on and off, should be through the gap in the middle. And I always have to plug them in and try and figure out which one's which. So we need to keep an eye on that. We're also going to do use some annotations. That's because the circuit we're going to build today is quite a bit more complex. So what we can do is we can use this little button up at the top left of Tinkercad, and we can actually drag that down, and we can just write ourselves notes on top of the circuit. And that just means we can keep an eye on what we're doing. I've got an absolutely terrible short-term memory. So if I don't write things down, then I will forget very quickly. So that's very useful for us. So I'm going to show you this final circuit. If I can get, I have to go to another window. I had to reset my computer. Now everything's gone missing. So I'll do the final circuit, and what we're going to do today is we're going to basically build a much basic version of a device I've been working on recently, which is an add to my shopping list button. And the reason for that is after lockdown, I've started doing the family shop, and the problem is my wife isn't used to this yet. And when she when she used to finish something up, she'd remember that and then go and buy it from the shop in the shop when we did shopping. And the problem is that I don't have her memory. I don't know when she's finished something, and therefore I don't tend to buy the right thing in the shop. So my idea is to have some buttons that are kind of along the bottom of the cupboard, and one will say beans. So if we finish off the beans, you can press the beans button, and that will add that to our shopping list, and then we can jump in that remotely and check what we need in the shop. So it's a device to make my life a bit simpler. So here's a here's a basic version of that. I've actually built this up now with 10 buttons, which is working quite well. So I've got 10 buttons, and then I can actually, the device I've built, you can access via the Wi-Fi. I can't at the moment, Rob, but I can share that with you afterwards. I've got some of the slides to go through first, but I will put that back on for you if we need to afterwards. So the idea is that when we start our simulation, here we go. I'm just going to pull up the monitor so we can see what's happening. So I press a button. I'm going to press a button. I realise that I've opened the wrong one, and it only does a few little things. But the idea is, you can see there that when you press a button, it will actually capture a reading. We can register what that reading is, and that will then go and store it. I will pull up the other one and show you that shortly. So one of the things I found restrictive early on when I started playing with Arduinos was the number of pins it's got in there. So the one we've been using, the Arduino Uno's got a reasonable number of pins. But I've been playing with the Arduino Nano, which has got less. And I've also been playing with a Wi-Fi processor as well, which has got only a few pins, and also an 8085 that I've been playing with, which has only got, I think it's 5 or 6 pins, which is really quite restrictive. So obviously, if you want to have multiple LEDs, multiple inputs, that can be a problem for you. There's various ways of getting around this. You can use some logic chips or multiplexing, particularly for the LEDs, but a simple low-tech way of separating multiple inputs, so you have multiple switches, is to use resistors. So we can build a simple circuit. It's going to have 4 inputs in it, but you can put more if you want to use a single input pin. I've done this, as I said, with 10, but the chap that I learned this from says he's done this with up to 50 different inputs, 50 different buttons or switches on a single input pin, and that actually that's quite powerful. So an extension that we need to think about, and this is going to be my final bit of talking now, is actually how to store this data for later. So it's all well and good being able to capture the pin and know that you've pressed button A, button B, button C, but obviously we need to be able to store that. We've got a few problems with that. So the Arduino's got 3 kinds of memory. And I'm going to ask you guys to type into the window again. So the first thing we need to understand is something called volatility. So does anyone know the difference between volatile and non-volatile memory? I'll give you some moment to type that into the chat if you do. I love your honesty, Robert. No, that's really useful. I'd rather know what you don't know. It's really, really good. Okay, nothing. Oh, here we go. So Simon says volatile memories are raised when the device powers off. Lily's question about substantial. It's not really substantial. It's it is down to the power really. Oscar says lost when the system is switched off is volatile. So that's exactly it. So if the power comes off, then anything that's in volatile memory gets lost. So if you think about your computer, the RAM holds. Yeah, it's linked to that, Serhan. Yes. So the RAM holds your operating system and your programs that are running and the open files. When you turn the computer off and on again, that all has to be reloaded from the non-volatile memory from the SSD or the hard drive back into RAM, which is why you lose. If you've not saved your documents, this is why you lose them, because you've not saved them back into non-volatile memory. So the Arduino's got 3 kinds of memory. It's got flash memory, which is basically the same technology as an SD card. It's non-volatile, but that holds the program. We've got something called SRAM, which is volatile, and that holds all the variables. So the stuff it uses as it's running gets held in there. But when you turn the Arduino off and on again, that gets lost, which is why if you had a program which lights up LEDs, after you press the button, when you turn the Arduino off and on again, the LEDs will need to be relit when you press the button again. And the third type is something called EEPROM. And EEPROM's kind of a halfway house. It is read-only, so it's not supposed to be able to be changed. But EEPROM is electronically programmable solid ROM memory. So it's ROM memory that can be changed. So we can use that as non-volatile memory. It's got some disadvantages. So an alternative would be to plug in an SD card or a USB or use the cloud, something like that. That would probably be faster, is a bit more complex, and involves adding more stuff onto it. The EEPROM, however, is slow. And you'll see that when you actually come to clearing the data out of it, it does take a minute or two to clear the whole thing. It's also quite limited, so the Uno that we've been using has got about 1K, which is about 1,000 bytes. Each byte is a single character or a single number from 0 to 255. So there's not actually a tremendous amount of data there. You know, a sentence could be 30, 40 characters, so could use up 30 or 40 out of those 1,000 characters quite quickly if you cut storing text in there. The other thing is that, well, I mean, I say that there's about 1,000 in the Uno. Some of the bigger ones have got 4,000, but then some small ones, so the nanos I use have only got 500 spaces stuff in, which isn't a lot. And the other problem is the write cycle, so it does wear out. You only get about 100,000 write cycles, which is either you write a variable, you change a variable, or you erase a variable. Every time you do that, it wears out a little bit. And after 100,000, which sounds like a lot, but if you're doing a lot of data logging, may not be, then that can very quickly use up all the write cycles, and then the Arduino is no longer usable in that way. So I'm just going to, that's just a bit of things to think about. So what I'm going to do now, I'm going to put the link to the tutorial into the chat window so you can all see it, so you can link to that. And again, I created the tutorial as a video, as a PowerPoint, as a PDF. Use whichever version is best for you guys. I was going to work through it again, make the mistakes at the same time, but there's been a request for it to be shown on the screen instead. So what I'll do is I'll put that on the screen and leave it there, and then you can just pop up and ask me questions. If you're too embarrassed to ask the question in the public chat, then you're quite welcome to send me a private chat instead if you like. So I'm just going to really quickly grab that video, the link for you. So I'm just going to close that. So I am still here. So that's the video. So that's the tutorial. So if you click that, that should take you through to it. And I will put that picture back up on the screen for those who want to be able to view that instead. Things to be aware of is that there are resistors. If you're just going to copy blindly, there are resistors underneath there, and the positioning is really, really important. So that's my talking done. My throat is now sore. So feel free to jump onto that tutorial, choose the version you wish, try and build the try and build the circuit, put it into 4 sections. So hopefully you can at least get the first 1 or 2 working. I've also, for those who prefer, put the codes at the bottom as well, again split into the 4 parts. So build away and question me as and when you need to. Sorry, Robin, I'm not sure what you mean by what. So I've put a link just above your what comment there, Rob. I've put a link to a tutorial to follow through to build the circuit which is on the screen. So just like we did last week in Tinkercad, we're going to build through a circuit. We're going to program it, and we're going to try and build this circuit on the screen at the moment. And what we'll do in a second is I'll swap that over to one that works, so you can see that it does work. Right, so that's now a working one. See that it registers the buttons, and then I can actually show what I've put in the memory there as well. Yes, I certainly can, Lily. Well, I'll also send you a link to the previous tutorial as well, so you can look at that if you prefer. So if you just give me one moment, just on a different screen, and I'll get that to you now. That second link I've just sent you is the material from last time, and I believe the recording is available on the YouTube channel, but I will put that into the web page as well when I find it. I use 220 ohm mark, and the reason I did that is when I built this in real life, I've got loads of them because they tend to be the ones that I got given when I acquired when I was playing with some LEDs. There are alternative ways of doing this with varying values, so this isn't the only way to do it. But I found 220 ohms seemed to do quite well. Zubi, are you looking at the screen I'm sharing or at the tutorial? Yeah, so I mean, this is meant mainly for illustration. If you look at the tutorial, I can put a direct link into there if you like, actually, for that. But if you look at the tutorial, you'll be able to see them a little bit easier. I'll just try and grab the right page and bring you straight to it if I can. So the link I've just pasted in, it takes you straight through to the PDF. And if you scroll down about halfway, you'll be able to see the full the full picture without the annotations there. If I can move these out of the way. Alternatively, I'll see if I can move these for you, so maybe I'll see a bit better. So when it comes to this lot, you've got a plus there into the right hand side. The LEDs go right hand leg to right hand leg, right hand leg, and then from there to ground. On this side, we've got the yellow goes left leg to left leg to left leg to left leg to this resistor, which then goes down to ground. I'm glad to be difficult for me to judge because obviously I can't hear what anyone's saying. And normally, if I was in the classroom, I'd be able to see people, whether anyone's bored or whether anyone's enjoying themselves or engaged. It's really nice to hear you saying that. Thank you. What I've tried to do is when I've tried to pass on some of the learning I've done. So these are things when I've had a problem to solve, rather than just taking through the rote introductory tutorials which you can get from the Arduino website. I actually looked at where I've had a problem to solve with something, and I've had to go and learn stuff that's been a bit more difficult to figure out how to do, because sometimes you don't even necessarily know the right question to ask. And then I've tried to share that learning rather than just the instructions. No, thank you. As we're around about halfway, could people just give me a bit of an indication of where you're up to? Because obviously last time I was trying to work through it with you guys, but because you've had the request to leave on the screen, I'm not doing this. So, like I said, I've developed the whole thing into 4 parts. I'm hoping that people are getting towards the start of part 1 being done. The lesson soon on to great. Thank you, Tom. So one thing I did mention as you was around by that stage is what you can't do is just use the numbers that it gives you. You can't use those as rock solid. And I was amazed by the variation when I run this on a real device rather than simulation. I was amazed by the variation I was getting from the numbers. There's just so many things to fear with it. And the biggest thing could be just be the temperature of the resistors. So a difference of a few degrees can make the numbers you get coming through, the actual resistance of the resistors can be quite different. Of like 10 or 20 either side sometimes isn't really unrealistic. Thanks, Samuel. I thought you know that.
Ollie, are you still there?
Yes, I'm still here.
Oh, brilliant.
Well, it's quite strange, which I'm sure you've seen when because obviously people are so quiet.
Yeah.
So I'm just waiting for people to ask questions. So Robert wiring. Sorry, can you go ahead, Richard? Sorry.
Okay, I won't interrupt. Sorry.
No, please. I was just seeing where Robert Darren up to. what would be really interesting here is if anyone's run into any problems yet. Anything they've struggled to. I know that we sort out the resistor values earlier on, but if anyone has run into any problems, I'd really be interested to hear. Because I did have some problems like when I made this circuit. I did run into a few issues, and it'd be interesting to see whether other people see the same thing as me. So if anyone's had any problems yet, it'd be really nice if we could put that into the chat and share it with everyone, so we can all learn from one another. So are you referring to this one here, Lily? Okay, this one here then above A. Okay, so what happens is it runs from here, it runs all the way through these if there's nothing, and then goes back to there. And actually what that does, so the bottom right one is acting as a pull down resistor to pull the signal that's coming into A0 down to ground if it's not getting anything through. What's happening here is actually the code has to have somewhere to go, else it's not going to do anything. All we're getting through the bottom side is the signal, really. So what happens here is we have it running through from positive round to ground, and what could conceivably happen is the power could come through here and then back through to ground there, and without that resistor there, it would cause short circuit, which, as I'm sure you're aware, can cause things like fire and smoke and all sorts of bad things. So, and I've very much, I'm not an electrical engineer. I've been learning this on the job. So from what I can gather, that one there is just to stop to stop short circuits happening. Whereas this one at the bottom right hand is there primarily to stop, to pull it down so that we don't get a floating voltage. Although if there are any electric engineers around that can prove me wrong, I'd be more than happy to learn, because I love learning and I'm fully open to accepting I do make mistakes. It's great to hear that kind of question, Lily. A, because if you're wondering it, it's a good chance other people are wondering it as well. Which is why I always encourage people to ask questions, no matter how daft they might think it is, because even the simplest things, if you're thinking than somebody else is, and that wasn't a simple question, But the other thing is it gives me the opportunity to think about it myself. And every time I look at this circuit, I have to try and follow everything through and figure out what's happening. So it's a good opportunity for me to think about it as well. Thank you. So in terms of time, ladies and gentlemen, I'm going to give you about another 5 or 6 minutes before we start drawing the practical aspects to a close. Simply because I'd love to be able to just figure out where everyone's got to, what you've learned, what ideas you've got, and then look forward a little bit to what can happen next, if anything. So if I give you another 5, maybe 6 minutes, and then I'll be asking you to come to a close for the practical aspects. Most certainly, Sam. I'm a commensurate discusser. I love talking to people about things. So I'll drop my email into the chat, and you're more than welcome to drop me an email. I can't guarantee I'll be able to answer questions, but I can definitely guarantee I'm happy to have a conversation about it. So I'll just stick my email into the chat now, and I'm more than happy to hear from anybody that does want to learn to type properly. So the email I put there is linked to my. I do many things, but one thing I've been doing for a long time now is running an education consultancy company. And I'm not very good at this company because I prefer the conversation with educationists and people who are being educators rather than actually making money. But this is something I'm getting really excited about. So yeah, that email there will probably be the best one to get me on. No problem. That's a great question. It's an absolutely fantastic question. My first argument is that I consider Python no longer my strong suit, and in realistic terms, I would consider learning another language. So I mean, I'd never, apart from once back in the very late 90s, I'd not used a C-based language before. I've used Pascal, I've used Python, various other languages in education, but I've never actually used a primarily C language. And I learned it when I started picking up Arduinos about 5-6 years ago. and I quite enjoyed it. So my teacher voice would say, don't let Python be your strong suit. Learn, expand your knowledge. However, if that's not what you want to do, the microbit yesterday or the day before, the microbit you can run MicroPython on. So there's an IDE called MuPython, and you can install that. It runs on Windows and Mac, and I believe Linux. You just plug the microbit in, press go, and it'll work. So that's an option if what you want to focus on is playing with a microcontroller rather than circuits. The connectivity on a microbit isn't quite as good as it is on an Arduino. It may be possible to run some version of MicroPython on the Arduino. I'm not sure. And the reason for that is I've never really looked into it. But what I would like to hear is if you do find out one, either whether that's suitable or whether there is another microcontroller which is more suitable for developing Python. I'd be delighted to hear that because, as I said earlier, I love learning these things. So, sorry if that's not the answer you're looking for, I'm afraid, but I don't have a lot of experience of using Python on anything other than the BBC microbit. Right, so we've got 8 minutes left before the session's due to stop, although I'm happy to hang around a little bit. What I'd just like to think about, because my final slide there is why people are finishing up, is I'd just like you to really think about what mistakes have you made as you've been going through. Sorry, Zubi, I'll come back to that in just a second. What mistakes did you make? What oddities did you discover? How did you solve problems? And then can you think of any uses a similar circuit to this could be put to? Like I said, I use it as I'm developing it as a remember to buy more beans button, but there's other things you could use that as well. So have a think about those questions, put them into the chat as we're going, and I'll just go through what people have said and try and respond to them. So Zubia, the output, if I click back to that screen, you have to open up the code, and then down the bottom there's a little button that says there's serial monitor. So you need to pull that up to be able to see what's in the serial monitor. And then if you've got the show working, for example, that will come there. Any of the things from the button you're pressing should show there as well. Lily, I will most certainly be in tomorrow. I will hang around a little bit at the end of today as well. I've freed up a bit more time after this session. But yes, I'll be in tomorrow to chat, really. And I'm delighted, I'm really excited, in fact, to hear what people have come up with, because it sounds like a great idea. This whole just coming together of possibilities. Shreya, so if that's not how you say your name, I don't know if you can hear me now, but obviously this will be recorded, so you can go back and look at that if you need as well. So has anyone got any wild and wacky ideas of what you could do with something where you could have a whole bunch of input buttons? Like I say, actually adding on a little extra control pack to be able to jump into this through the internet and be able to read that data over Wi-Fi or over the internet is quite viable. So any ideas people have got what we could do with this, I'd be delighted to hear. Mainly because I've got a bag full of buttons and not much to do with them. So either everyone, excellent. Sorry, Thomas, I was about to jump in front of you there. Thomas, you can look for some multiple. Yeah, I mean that's really interesting actually. I mean, what wouldn't happen here? It can't. I don't think you can press multiple buttons at once using this method. But if you're, I mean, I've got a piano and I only play that one key at a time because I'm rubbish, mainly with my right index finger. So yeah, I mean, for a simple thing like that, it could work really well. Tom, I'm not sure what closed list is. I'd be interested to hear a bit more about that. If you could maybe give us a little bit more detail. If it's not working, again, it depends. Is it not compiling the text, or in fact, what might be better, Robert and Aaron, if you maybe print screen what you've put and send that through to me in an email, rather than try to describe the what's happened. I might be able to look a bit better from that. Serhan, yeah, that's a wonderful idea. I saw a great IoT device. Well, it wasn't IoT; it was an Arduino device a few years ago. Tom, where a chap had an autistic son, and his son struggled with language and words. So what he did, he had a little RFID reader, and he had the kid's favourite albums he had printed out on cards with an RFID chip in, and he just put that over a receiver, and it would play the boy's favourite albums. And I thought it was such a wonderful idea. And again, this could be used something similar. So somebody that's that's got some sort of motor issues where they can't necessarily use their hands as finitely as we might be able to. Instead of having loads of different buttons to do things for them, it just opens up loads of possibilities. It could be each one could be a different emotion that people could press to share their emotions. I know some of the Open University done some research about colours and feelings on different colours, and this could be something similar. You could use it to assign a colour to your feelings. Samuel, yes, sorry, I thought I'd caught that correction. So yes, it should be EEPROM, not EEDPROM. I apologise, I'll get that corrected and re-uploaded. So everyone makes mistakes. I just tend to make more than most people. But in terms of your from there, I noticed we've only got 2 minutes left before it's due to end. Obviously, you can send me that email through if you wish, whenever you want to. It's probably a connection not quite right somewhere. It's very easy because obviously the screen's quite small. It's easy to get in the wrong pinhole. So if you just ping that me an email through, we can enter into a conversation and try and help you fix the problem. It's probably something minor. Like I say, I mean, this took me a few turns to get right. I was doing it from memory, and you don't need to worry about when that comes through. We'll get through to you as soon as we could. Samuel, yeah, and like I say, they've got some really clever logic chips which you can actually daisy chain. So there's it's called a Max 7 something or other, which will let you run, I think it's up to 8 or 16 LEDs from one chip, and you can daisy chain that on through to about 64 chips, and they only use 3 output pins. So with 1 input pin and 3 output pins, you can do loads of stuff there. And the LEDs could easily be actuators to dispense food and drinks, and it doesn't take much. It doesn't take much to do that kind of thing. So there's a great opportunity. Right, we're coming my clock. We're dead on 3 o'clock. So as an official, we'll draw an official line under that and say done. It's been wonderful speaking to you all again, and I hope that you've enjoyed going through this as much as I enjoyed creating it. And like I say, I really have enjoyed creating these because it's a wonderful opportunity for me to think about how to do different things and how to try and keep it a little bit interesting. I will stick around for a little bit longer. In case anyone's got any discussions or any other questions they want to ask. But please feel free to drop me a line if you want to, either via the email or at Mr_Howson on Twitter. But other than that, I will pass back to Richard. Thank you very much for your time. Thank you.
That was a fascinating session. Thanks a lot. That really great stuff. And I was just thinking, saying to some of the participants to take screenshots of I guess what they're doing on Tinkercad, so that you can look at them. And it did make me think slightly. If people do want to actually submit their ideas for a challenge, using an Arduino. How do you think, what would be the best way for them to do that? Should they do screenshots of an emulator, or what do you think the best way to do that would be, Oli?
If they're doing it in Tinkercad, they can actually make. I think sharing is a wonderful thing. It's incredibly powerful, and it's something which is becoming more and more prevalent. Robert, now if I can finish this, and then I'll double check for you. So I think more and more people are sharing things freely these days. I think it's a wonderful way the world's changing, and a lot of software such as Tinkercad allows that to happen now. So these all these texts I've been making public, and you can just share the link. So if anyone is creating an Arduino based project and they want to do it on the emulator, they could just submit the link to us, and we can then go and actually do that. And the great thing is, Richard, that we could then run these circuits and see them working, and we can. It's almost as good as having it in real life, really. So I think that would be a really good opportunity. If that's something that's not going to work, if they're wanting to build things in real life, again, actually, the Arduino itself has got a web-based editor these days. You don't have to download the software; you can do it from the browser. So they can make that public and share their code with us. But obviously, we need to see, well, we'd like to see pictures of the device they build as well, I suppose.
Brilliant, thanks. And I think Lily's going to ask if we could do something similar for Microbit. I guess we could, couldn't we?
Certainly. Yeah, I mean, I don't see why not. Again, I haven't used the online editor for Microbit for quite a few years. I've been using MicroPython instead. But you know, I think the important thing for us is that we can see the creativity that's coming through, and I think really, you know, as a member of the panel, that's what I'm interested in, and how people choose to share that with us is absolutely up to them. I mean, I'd be delighted if we got somebody making us a song about what they've done, but you know, if we can't have that, then I suppose screenshots would be just as good. Yeah, Lily, it's a microcontroller. It's, you know, it has connectivity via Bluetooth, via radio, via other things. It's a device that can be. It's a thing that kind of connectivity. So I think it certainly counts as part of IoT.
And Lily as well. I don't know if you were around last week for it, but David Pride did a masterclass for Microbits on Friday, and you can find a video of that on our YouTube channel. So if you do, you know, if you want to watch what David was doing with with Microbits, then please do watch the video, and you'll see details of that. Oh, brilliant! So you were there. So anyone else? Just check out on our website, www.seras.org.uk, and there's details of where all the last videos are and everything.
And Robert, I did get your email, but it's got no attachment on it, so if you want to send the screenshot whenever you like, that's absolutely fine. Thanks, Trish. Great speaking to you again.
Has anyone got any more questions for Oli?
Okay, so just to remind everyone before people do all disappear, if you wanted the resources from last week, I'm happy for Richard to share that. You can also jump into the website, and it's just the previous link in my website, so you can access all the code and the tutorials and things there as well.
And just to say again, please do all come along to the session tomorrow, where we'll be there. We'll have lots of makers there and things to answer any questions you've got.
Zuby, I'm not really sure what you mean by interface board. Is that something specifically, or do you mean an interface board in general?
Do you mean the Arduino boards and the Microbit boards? Oh, Ollie, I'll leave that on to you.
I think there certainly can be. It doesn't need to be. I don't think we need to worry about a hard and fast definition of what IoT is. As far as I'm concerned, it's things that have got connectivity. Now, a 5-axis step and mode control board in itself doesn't generally have interconnectivity with the greater internet or even the local internet. But if you were to link that up to an Arduino or a microbit or a Raspberry Pi and be able to send instructions from your phone to a CNC machine, then yeah, that becomes part of IoT. It's not about trying to figure out what is part of IoT. I think really the interesting thing is, what can I make part of IoT? And the thing I sent earlier on, sorry, I don't know what Mach 3 is, but we'll have a quick look while I'm chatting. But yeah, the thing I saw earlier on was using bits of old milk bottles as part of the device. Is a milk bottle part of IoT? No. If it's plugged into an Arduino to make it do things, then I'd say then that milk bottle becomes part of it. So I'm just pulling up the Mach 3 website while I'm thinking about that. So that turns a. So that basically allows you to connect a computer up to a CNC machine. Certainly, I don't see why not. Now, obviously, a computer controlling a CNC through Mach 3 is not very creative, because that's what it does. If you're doing something creative with it, then it'd be something that's perfectly viable. But what's like, and I noticed this before, what's important to me is the creativity of what you're thinking about. Are you thinking of something which is really kind of cool? And that cool factor, it makes a big difference. So, but yes, from my little understanding, if that is a way of taking a computer and connecting it to a CNC machine or a CNC machine controller, that's got potential to be pretty amazing. I used to run an engineering department in a school in Banbury, and so I just loved playing with machines and seeing them make things. So I think it's got loads of potential. Depends what you want to do with it, really. Thank you. I've learned something as well. I've now learned what Mach 3 is, so excellent opportunity for everyone. Thank you, Mark.
Well,
So for those who are still happy to hear me whittering, I was in a meeting with David Price a week or so ago. He's been making remote control aeroplanes, and he's inspired me. So I went down to Hobbycraft and bought £10 worth of foam. And my current brain thoughts are how to get an Arduino inside a foam-based remote control aeroplane, and what I can do with that. So I've got an airplane, I've got an Arduino, and let's just figure out how to put the two together. That's engaging my brain at the moment.
Right, Ollie, thanks so much. I think we'll wrap that up there, everyone, if that's okay. Any more?